Here I am going to solve one more problem based on frequency sampling method. Here it's given, instead of low pass filter, it's directly given as a band pass filter. In this problem, observe here, just checking for band pass filter. Okay, with the following specification, it's given filter coefficients of the length. Sometimes they may give m values or else n values, both are same, don't confuse with this. Okay, sampling frequency they given, that is f is equals to 8000 hertz, and cutoff frequency is given as fc1 and fc2. Actually band pass is of, it's going to vary in a 2, omega c1, omega c2. Okay, in this what is the given, first you can write off those. Sampling frequency is 8000, cutoff frequencies are 2, that is 1000 and 3000 hertz. First we have to find what is the desired frequency response. Before that we have to find what is the frequency response for those. For that reason we are going to consider of omega c1. What is omega? 2 pi f. Here omega c1 means 2 pi f c1. Okay, fc1 can be obtained by cutoff frequency of first divided by sampling frequency, that is 2 pi 1000 by 8000, you will be getting as pi by 4. Then omega c2 is equals to 2 pi fc2, 2 pi fc2 divided by sampling frequency, same way. Okay, 2 pi into 3000 divided by 8000, you will be getting as 3 pi by 4. Here we have drawn the diagram for this, how a band pass is going for. It's not a actual band pass, how it's going for. Here a assumption, it's a, we take everything in a practical, it's not in going to be practically, it's going for the diagram, just in a imaginary way. Okay, here our h of k is going to vary with according to omega. Band pass filter for 0, you don't have any signal here. Okay, then from pi to 3 pi by 4, pi to 3 pi by 4, a signal band pass filter is taken. Okay, then the same is going to be repeated from pi to 2 pi. Okay, 0 to pi and then pi to 2 pi, but our signal is represented in from pi to 3 pi only. Same thing here it is taken. Okay, then desired frequency response, hd of omega is equals to, observe here n is 7, for that reason it's odd number, for that reason e raised to minus j omega m minus 1 by 2. Here our omega is varying from pi to 3 pi by 4 to 3 pi by 4. Okay, only in this case only. Then for other values from 0 to pi by 4, we don't have any signal here. Observe here, from 0 to pi by 4 we don't have any signal, for that reason it's 0. From 3 by pi to pi also 0. This is what the equation we will get. Next we have to substitute for m value as 7. In this case, if I substitute 7 minus 1 6 divided by 2, that is you will be getting as minus j 3 omega. Here also limit remains same. Next, this is what step 1 where we got the desired frequency response. Next what we have to do, we have to go for what is the sampling of desired frequency response. In this case we have to substitute omega as 2 pi k divided by 7. M value is 7, for that reason substitute as 7. Substitute omega as 3 pi k divided by 7, the limit as it is. Okay, here also in the limit also we have to change for omega, that is 2 pi k divided by 7 in for both the values. Okay, next after this Again, next we have to solve for the limit. Instead of going for fractional part, we have to take for the integer values here. Okay, if we solve, we'll be getting as 0.875, then 2.625, and again varying from 0 to 0.87, 2.6 to 3.5. First, in this case, 0.8 is nearly 1 value. For that reason, we are going to take it as 1, and 2.6 is a lump somewhat, it's not going to approach there. For that reason, 1 to 2. Next, from 0 to, already 1 is taken here. For that reason, it should not overlap. For that reason, we are going to take k as 0 only. Next, that second limit, we finished off 0, 1, 2. Next, we have to consider here as k as 3. Only thing we have to consider here, it should not overlap when we are going to choose the k values. Observe in the figure. If we observe here, k is 0, k is equals to 1, 2, and k is equals to 3. Within this, our signal is going for. When k is 0 and when k is equals to 3, we don't have any signal. At the point at k 1 and 2, we have a signal. We have to consider of that, and we have to take the limit for k in this case. This is how we are going to take the limit. Next, find step 3 is finding the impulse response. Use the equation. Again, the same equation. Just substitute h of 0, then h of k. What is the m minus 1 by 2? If you substitute this, you will be getting the values. Next, to get h of 0, observe here in the figure, h of 0, if I substitute here, we don't have any signal. For that reason, in this section, what I am showing here, fully blocked, here we don't have any signal. For that reason, h of 0 is 0 only. Okay. Next, substitute for m value, k 1 to 3, then substitute for h of k. What we got in this case, e raised to minus j 6 pi k divided by 7, then this part remaining as it is. Next, do the simplification here. Take 2 pi minus j 2 pi k as a common. Remaining part here, if I take minus j 2 pi common, you will be getting as 3. From this, you will be getting as n minus n divided by 7. Again, we are going to consider only the real part in this case. For that reason, only cos 2 pi k 3 minus n divided by 7 you will be getting here. Okay. Next, here k is varying from 1 to 2. If I substitute k value for 1 and also for the 2 value, 2 pi, here 2 is taken outside, 2 by 7 cos 2 pi k is taken as 1, 3 minus n divided by 7 plus cos 4 pi 3 minus n divided by 7, multiplying. This is for k is equals to 1, here this is for k is equals to 2. Observe here, n is varying from 0 to 6. In the problem, what they asked, determine the, here what I am showing here, we have to determine what is the filter coefficients. For that reason, we have to substitute for n values as from 0 to 6. Length is given as 7, means 0 to 6. If you substitute h of 0, where is n, substitute as 0, then you will be getting as minus 0.0793. Next, in the same way, go for substituting h of 1, you will be getting the result as 0 minus 0.321. In the same way, go on substituting, you will be getting the result as like this. Okay, this is what the problem it's given in terms of band pass filter design. Keep in mind what is the length it's given and which type of filter they are asking in the exam.